Good evening to all the students of ME second semester who are studying in the hydrosystem engineering in the GTU, and today we shall go through the syllabus of module number 4 through the PDF and my lecture sheets. But before going that, we shall discuss about the content of the syllabus, and even before proceeding that, I will request you and there just the formal warning about the COVID-19 corona, that stay at home, stay safe, and please maintain the routine of being self-quarantine at your home. Now we shall discuss about the water resources optimal allocation problems. What are these problems and why optimization comes into the picture for referring the problems of water resources engineering, how the optimal allocation is done, and how the multi-objective problems are being solved using the optimization in the water resources sectors. What are the methods which are being employed in working with the water resources problems? What are the different case studies that we shall go through about the case study of rainfall runoff modeling, case study of the reservoir operation, case study of the dam irrigation management, and also we shall go through the case study of the storm drainage network. So we shall proceed all these things in the PDF, and also my PPT and the PDF has been shared with you. You can refer to that also, and with this content we shall proceed towards the content of the PDF in this video.
Optimization is actually very broader term or a broad discipline which is used along with the mathematical or computer based programming itself, and many of the aspects, many of the constraints are included in the optimization. So first of all, we need to understand what does optimization means, or what are the optimization techniques or methods which are being used nowadays. As far as optimization is concerned, in a very simple term, it means the minimum input and we will get the maximum output. Means we will frame the input and output in such a way, or we will input our efforts in such a manner so that we will get maximum output or maximum profit. So the optimization may be of the two types. That may be minimum or maximum. So minimum allocation, in the minimum type of problem, our objective function will be to minimize the losses or to minimize the errors. The second methods or the second objective function may be to maximize the profits, to maximize the benefits, to maximize the uses. So actually it includes in the optimization. And optimization is also concerned with the day-to-day life activities and practices, so that we would want some best results out of our small efforts. So that actually comes under the optimization. Many combinations which are feasible or not feasible, whether those are countable or not countable, and when data sets or the population is very large, the sample data is also very large at that time, and we want some optimal allocation of the problem. At that time, the optimization is there to help us. There are different optimization techniques which we can go through, and these optimization techniques are linear programming, non-linear programming or methods, quadratic methods, dynamic methods, stochastic linear or non-programming is there, soft computing methods, artificial intelligence is also there. The optimal allocation in the earlier days, which used to happen with the methods such as the linear or non-linear optimization methods, using the simplex methods or non-linear based methods as well. But nowadays, the soft computing techniques or artificial intelligence, neural networks, these are being used. So particularly the module number 4 and module number 5 are basically dedicated for studying this type of optimization methods, optimal allocations, the case studies, and most importantly to study the soft computing techniques. These are the techniques, linear programming, non-linear programming, which we have gone through, and this type of programming or the techniques are most commonly used nowadays for the optimal allocation of the water resources engineering. And there is one broader term sometimes used in reference whenever the soft computing or neural networks are used, that artificial intelligence and computing is used. So optimal allocation and optimization, it has two broader aspects. One is the hard computing, one is the soft computing. When we are employing the use of or utilizing the methods such as conventional methods, which includes mathematical framework, mathematical modeling, and the calculations will be done by using the pen or paper like that. So that comes under the hard computing, and the other methods that will come under the soft computing. So computing actually means counting or calculating among large number of data when the data sets are larger, and conventional mathematical methods are not suitable for using. The artificial intelligence, actually when the intelligence is induced in a machines, it is known as the artificial intelligence. Two other terms such as machine learning or deep learning is also used, but those comes under the artificial intelligence itself. Artificial intelligence is actually governed in the computer based sectors, but it is also being used in the optimal allocation with the use of artificial neural networks and other methods such as like image recognition or data based information modules as well. So we shall now proceed towards the PDF of lecture notes for the module number 4. That will, in that module we shall go through the case study which is being given to understand the different type of optimal allocations and the problems in the water resources, because water resources itself is a very broader discipline, and how the optimal allocation or optimization techniques are actually used in the water resources as far as research is concerned. Now let's move towards the lecture notes of module number 4, the water resources optimal allocation. The hydrosystem engineering and management constitutes of various mathematical and computational methods which are being employed to study the problem of water resources in various fields of hydrology, hydraulics, and water resources using the mathematical methods such as linear methods, simplex methods, other mathematical advanced methods, and computational or computing techniques as well. So now basically this module is dedicated for the water resources optimal allocation, in which various case studies by the different researchers will be studied in detail. So first of all, we need to understand that optimization that we have gone through a little bit in the last a few minutes before in a PPT about the general overview of the optimization, and recent developments have shown that the optimization in water resources is actually a very vast, very important, and very efficient emerging methods, because irrigation releases, the hydrological management, hydraulics aspects, irrigation and hydraulic structures, the reservoir releases plays a very important role. So water resources is itself a very core and very vast area in which water resources in which the optimization for water resources and optimal allocation can be studied. As we know that various sectors and various examples are there which are not confined towards the use of a particular water in a single segment or linear or non-linear methods or mathematical computations, but also it has a very vast scope in the field of hydropower, navigation, canal management, water supply, and various other segments are there. And a large extent on the objective economic benefits obtained from the whole valley on the objective of reservoir storage itself. Various examples of optimization and optical allocations are the experiences in multi-objective planning and management of water resources system. Then uncertainty is always there in the optimized reservoir operations. design and management of water resources system by polyhedral dynamics, then fuzzy modeling for forecasting discharge in water level of large rivers, physical based models for hydrological cycle and application to hydrological calculations and forecast, an assessment of project risk estimation, uncertainty in hydrologic design, probability of extreme low flow during various durations, then uncertainty in reservoir design, benefits from using secondary data, a multi-state data generation model for daily discharges, long period weather records, droughts and water resources. And these are also a few examples regarding the microcomputer data banks for operational research, hydrological research and developing countries, potential water yield in semi-arid areas, reservoir storage yield analysis, use of generalized computer programs for resources system optimization, flexibility, a key to the management of risk and uncertainty in water supply, the derivation and use of control curves for the regional allocation of water resources, optimal allocation of water resources subject to quality constraints. Actually, these are not only the examples of optimal allocation, but also the fields in which optimal allocation has its scope. There is a wide scope including the stochastic dynamic programming, wide scope in uncertainty in the water supply, in the canal system, in the hydropower system, various in the reservoir operations, the releases and the inflow and outflow based studies. So there is a vast scope, and also it has to be efficiently and effectively manage the water within a catchment area or within the valley, and the storage must be utilized in the most proper, effective and optimized and economical manner as well, so that it can yield something to the country as well. And the emerging technique is also the operational allocation of the developed sources to meet the water supply demand and real-time management of the water resources in low rainfall areas, because water is a very important natural resources, and wherever it is applicable, it has to be used and utilized by most of the people. And in the area of the low rainfalls, the real-time management must be used and incorporate for utilizing the optimal yield. These are the analyze the methods of optimal allocation and optimization techniques for water resources. So there are various optimal allocation methods are there that is studied between the module 1, 2 and module number 3, and various techniques are there, linear methods, non-linear methods, simplex method, uncertainty based methods, mathematical modeling is also there, then computational methods, soft computing techniques. So there are various methods of optimal allocations are being available, various softwares are being used, such as Loop, water gems for the water supply schemes, etc. So optimal allocation can be managed, and various optimization techniques for the water resources is also being given. Then explain the case study of reservoir operation for inflow outflow storage of water. Actually, this case study of reservoir operation is being studied by J.W. Delure et al. Based on the uncertainty in the reservoir operation. Actually, reservoir operation is a very critical and stochastic as well, stochastic in nature as well, and the determination of the annual and monthly reliabilities of a single reservoir with releases regulated in which the losses were minimized. So they have studied regarding this. So this was one of the case studies that has been taken from a research paper, and that has been presented here just to understand the problem. What were the problems related to the reservoir optimization and optimal allocation of the reservoir, and it was studied. Then also based on one more reservoir problem was there, which was studied by R.B. Buchanan et al. A study of a real-time adaptive closed loop reservoir control algorithms, and in which a real-time closed loop reservoir algorithms were developed from a steady state stochastic dynamic programming solution and that from a real-time adaptive control formulation that was used for the multi-lead forecast of the river flows. And the objective of that study was to minimize the loss due to irrigation deficits, power production deficits, and damages. So these were the optimization techniques. In the PPT also it was covered that the optimization techniques converting to the computational aspect has been given here. The computing, as far as computing techniques is concerned, a separate module of soft computing technique has been prepared and floated already, and these are the techniques which are conforming to the soft computing modules, because soft computing are those methods or techniques which can be employed and give far more better solution rather than the hard computing. Because hard computing, when becomes tedious, the parameters or variables becomes uncertain, more and more uncertain and stochastic in the behavior, then at that, and methods become dynamic in nature, so at that time the computing techniques in the optimization are being used, which may be linear programming, non-linear, quadratic, dynamic, stochastic, linear or non-linear, and the soft computing as well. So this soft computing particular has been dealt separately, and other techniques. So in the optimal allocation, these optimization techniques may also be used. Then the case study of irrigation water demand with suitable numerical and data and multipurpose use of water resources in the irrigation by L. David. So he has studied about the irrigation water demand, how this demand can be fulfilled. This was given in the research paper. A detailed overview of the research paper can be done by the student separately on this research paper, but actually multipurpose, how a particular water resource can be multi-purposely used, in which the irrigation is the prime purpose or prime objective of that particular use. So it was to estimate the water resources available for the other users in supplementary irrigation system and to describe the constraint of this multi-purpose use. So mathematical model was presented by them to categorize the water demand of the irrigation system. So this particular mathematical model was prepared for optimizing the optimal allocation of the water resources for the irrigation purpose. And at last, the storm drainage with the suitable example is being given. So water design of drainage culverts considering critical storm duration by M.S. King et al. Has been given. So storm drainage actually is a big problem in metro cities, in mega cities, or even sometimes in a town or village as well, when the rainfall intensity or regular frequency create a very big problem. So low duration, high frequency or high frequency and high intensity rainfall whenever occurs in a particular city or particular area, it creates a problem of storm drainage. So multiple and number of research papers are available, and those can be referred to as a case study of optimum management, how that particular water can be drained off from a city or from a town in a very optimum time. And it can be also studied to evaluate the particular return period, or the effective design of storm drainage can also be proposed after going through those case studies. So these were basically what we can say is these were the basically methods and the techniques which were employed, which can be employed for the purpose of optimization, for the purpose of optimal allocation, pertaining to the and dedicated to the soft to the water resources engineering sector only, the hydrologic, hydraulic, irrigation and hydraulic structure based sectors only. So thank you very much for being in this video. And these optimization techniques and soft computing techniques have been covered separately in one of the module, and it was just an overview video. about the different type of optimal allocation, its uses in the theoretical aspects and in an exploring manner. You can go through the various case studies as well by yourself. So thank you very much for this video, being in this video.